Okay. Question number 12. We are sketching the graph of this polynomial. Some things to note. We have a triple root at positive 1, at x equals positive 1. We have a single root at x equals negative 4, and a single root at x equals 5. Okay. So I'm going to go ahead and plot those intercepts there. Negative 4, we have a single root. At positive 1, there's our triple root. And then we have a single root at 5. Okay. Because our leading coefficient is negative, that means that the general shape of our graph, well, we also need to take into account what is the highest power of x, and so we have an x to the cubed multiplied to an x, which would make it an x to the fourth, multiplied to an x, which give us x to the fifth. So it's an odd function, and with a negative leading coefficient, that means our end behavior something like this. Okay. Well, let's go ahead and start with that end behavior. We have a single root at negative 4, so our polynomial is just going to go straight through. We're going to have a local minimum, and then we're going to bend up towards our triple root at negative 1. Now with a triple root, we're not going to go straight through. We're going to kind of like a cubic polynomial. We're going to bend a little bit and have kind of like a little kink as we go through the root there. And then we're going to have a local maximum and then bend down straight through our last root, and there's our end behavior there. And that's what our polynomial should roughly look like. Okay. Number 13. We're going to sketch given the certain characteristics here. So we have a y-intercept at 2. We have a double root at negative 4. So I'm just going to mark that there. Little 2 to remind me that's a double root. We have a triple root at positive 2. And we have a single root at 5. And we know this is an even function, which tells us it's going to be this open parabola. We're not told whether it has a negative or not, but we'll just assume that we're going to be opening up. Okay. All right. So our graph in behavior towards negative infinity looks like that. This is an even root, so we're going to bounce off of that. Go to a local maximum, come back down. Then we have a cubic root. So we're going to kind of have this little bend as we go through. The root. And we'll drop down, have another local minimum, and then bend back up. And that's roughly what our graph will look like. All right, and then we're also supposed to graph y equals x plus 1 squared. So to do that, we are going to do that. We're going to plot some points. One point that's actually given to us, this is in vertex form, so we know our vertex is at -1, +5, so I can graph that. We could look at this as, this would be x squared, but with a shift -5 down and a shift left 1. That's one way we could look at graphing this. We could also set up a chart here, table, and we're already given -1, 5. Let's try plugging in 0, 0. We'll get 1 squared minus 5, so we'll have -4. So I'll plot that. And since we know this is a parabola, we get another free point. Erase that, that's not placed very well. So we get another point right here at -2. We're also going to be at -4 because of parabola and its symmetry. If we plug in 1, well, 1 gives us 2 squared minus 5, so it's going to be -1. And then we get a free point on the other side. That -3 is also going to be -1. And if I plug in 2, I'm going to get out 4. But also at -4, I'm going to get 4. Okay. And that's enough points. We can graph our parabola.